All right, so a whole lot of overlap, okay? There's really nothing new in this lesson. There's a little bit of a review from before Christmas on something we haven't done for a bit. And then there's a lot of overlap with 5-1 as far as using algebra, which is the wall, and moving things around to get these in y equals mx plus b, okay? So that just never goes away. All right. So this first page says that Beth and Dante pass by the library as they walk home using separate straight paths. And then it asks us, it says the point on the graph represents the location of the library. So this point right here, you don't have to mark this. I'm just doing it so you can see what we're talking about. This right here is the library. Okay, that's what they're telling us. It says draw and label lines on the graph to show each possible path to the library. So all you're going to do, and everybody's may not look the same, but you're going to draw a line that represents Dante's path, and then you're going to draw a line that represents Beth's. And the only thing I will tell you is make sure that both lines have a good B, because in a minute, we're going to come over here and write a system of equations that represents those paths, which means for Dante, we need an M and a B, and for Beth, we need an M and a B. So I'm not just going to like kind of just come over here and do something like this, because look what my B would be. My B would be like 2.4. I don't want a crazy B. So I'm going to be a little bit more methodical about my line. And for Dante, I'll do Dante in blue. For Dante, I'll make my y-intercept here. Okay. And it doesn't matter. You can make it higher or lower. Just put it on a nice point that you can name easy. Okay. So this is Dante's walk to the library. Whoops, that did not go through my B very well, did it? Close enough. Okay. And this is Dante, right? This is Dante's path. And then they said do the same thing with Beth's. And the only requirement here is that I would give yourself a good B, and it's got to go through that red point. So I'm going to, for her, I'll just put it down here. It doesn't really matter. And again, she's got to go through that library point. So that looks good for Beth. Now it says to write a system of equations. Well, all that means is you have to write an equation that matches the line you did for Dante, and you have to write an equation that matches the line you did for Beth. So if we go to Dante first, I'll do Dante here, okay? To write an equation, what do we need? Good, we need an M and we need a B. Now, because we were kind of thoughtful about how we drew those lines, what is Dante's B? Remember, B is where it crosses the y-axis, 2. So for Dante's B, it's 2. Now, if I use the library as a good point and the B as a good point, I can find Dante's slope, because I can go from the B up 1 over 2, right? And that's Dante's M, or his slope, up 1 over 2. And I'm going to erase that little, just so I can keep it clean here, okay? So for Dante, I can write an equation now because I have an M and a B, and it is y equals mx plus 2. Okay, a little bit of review from Christmas on how to write an equation based on a line. Now we go to Beth's line. Okay, so we're going to come over here, and we've got Beth. And for Beth, we need an M and a B, just like we did Dante. And Beth's B is what? Good, -2. So Beth's B is -2. And we need to do the same thing for Beth as far as finding slope. So we're going to come back over here, and from the B up to the library, count rise over run. Somebody tell me what you get. Yes. No. You got to go up 1, 2, 3, 4, 5. There you go. 5 over 2. Remember to always do whatever you got to do to create that little half box, right? Between 2 good points. So you rise and run, make a little half box out of 2 good points, and then count how much you rose and how much you ran. So for Beth, we rose 5 and we ran 2 to get our slope. So for Beth's equation, it's y equals 5 over 2. That's our M. And then you put the X, and then her B was -2. So I'm going to put -2. And we just wrote a system of equations that represents the paths. And the step further, yet last week when we did 5-2, all you were asked to do is look at the two equations and say how many solutions there would be. And you can look at these two and you can see that they have different slopes. So right off the bat, you know it's going to be a one solution system, which we already know that from the graph, right? They crossed at one point. So now we're actually going to say, where did they cross? So what is the ordered pair of where they crossed? Almost. You always do the x first. 2 over 3, or yeah, 2, 3. So the point where they crossed on the graph, the coordinate was 2, 3. So not only did we create lines, then we wrote equations for those lines, and then we looked and saw, which they gave us this, where the two lines crossed. That was kind of the whole focus of our problem. We made them cross at that point that the book gave us. But that point, and if you're ever not sure about how to write a coordinate pair, okay, it kind of always comes back to that box idea. If you will take your point, which this was our library point, if you'll go down to the x-axis, there's your x value of 2. If you'll go over to the y-axis, there's your y value of 3. And always think about alphabetical order. It's X, Y, Z, right? So X comes first in the alphabet. X comes first in your ordered pair. So it sits over the X of 2 and it sits sideways next to the Y of 3. Okay. All right. So that's just a little bit of introduction into what we're going to be doing. Okay. Nothing, like I said, nothing new. This is the one that I really want to take a minute on because this is a review from way back before Christmas. We've done this, but I'm going to kind of reintroduce how we write equations from these story problems, okay? Always when you're writing an equation, we know we need an M and a B, right? And in a story problem, and I'm going to focus in on this company A for a second. In a story problem or in a problem like this, you know your M is the one that moves or changes. So whatever one changes per minute, per hour, per day, whatever it is, the particular story problem, whatever one changes or goes up every, again, this one's minute, but it could be minute, hour, day, whatever. That's going to be your M because that's the one that moves or changes, okay? So we know in this particular problem, this is our M because it says 20 cents per minute, right? And if you see per minute, in place of minute, you're going to put an X because when we write this equation, that X is going to stand for, did you do it for 1 minute, 5 minutes, 10 minutes, 20 minutes? The minutes can change and we can plug that in for the X to decide something. But the minute is, or the per minute is just going to stay generic. Now you've got this plus $75. If you think back when we first started talking about writing these equations, anytime you have a processing fee or a deposit or a rental fee or anything that's what you pay the second you walk in the door, right? That's your beginning amount that you pay, and that's your B. Because if I go with company A and I use 1 minute, I'm going to pay that $75 fee. If I use 100 minutes, I'm going to pay that $75 fee. That's your base fee or your base rate. So that becomes your B. And with an M and a B, we can write the equation. Y equals, now my M is 20 cents. Think about how you'd write money. It would actually be 0.20x. Okay, that's 20 cents. The X stands in place of however many minutes you want to test this out on. You can try it for 1 minute or 100 minutes and see what you'd pay. And then plus the B, or that $75 flat fee that you're going to pay no matter what. And remember, in story problems, you might see that as processing fee, rental fee, deposit. Think of it as what you're going to pay when you walk through the door no matter what. That's your B, okay? So if we go to company B and we do the same thing, we see 25 cents per minute. When you see that per minute, per hour, per day, right off the bat, you got to think that's the one that can change. Whatever one can change, that's going to be your M. Okay. Whatever one is the base rate, the one that doesn't change, it's what you're going to pay no matter what, you know, that's going to be your B. Okay. And you might see kayak rentals. You might see phone companies. You might see moving companies, whatever. Okay. But you're always going to have to read into the problem and pick out which one moves or changes. And that's always going to, that's going to be your big key word there. and then which one is just your base rate that doesn't change. It's kind of your flat fee. So in this case, I can write the equation y equals, now again, it's 25 cents. So kind of be mindful how we'd write that. You can put 2.25 per minute. You're going to put an X in place of all the minutes that you can test. And then it's going to be plus your B, or plus your flat rate that you're going to pay no matter what. So now we've taken these placards, or these company A and company B's information, and from it, we were able to build equations, okay? That right there is probably pretty much the hardest part, is just kind of getting that back up in your memory from before Christmas, okay? So what they've done here now, and this right here was the work that we just did, right? They used the information to write these equations, and then they came over here and they graphed them. So if you'll notice, company, let's see, company A is in green in this graph. So our company A was right here, and the green line is company A's line. And then they did purple for this one. So here is company B, and company B's line is in purple. Where they intersect is the number of minutes that you can use. And again, you got to look at how your stuff is labeled. This is minutes used. So if you go straight up from this, or straight down from this point, this tells you that at 100 minutes, both companies are going to cost, and they tell you it's 95. Okay. So if you know for sure that you are going to use that phone exactly 100 minutes, doesn't matter which company you go with. Nope, because at 100 minutes, you're going to spend the exact same amount for company A or company B. Now, let's say you don't use a phone a whole lot. So you're like, yeah, I'm probably only going to use about 50 minutes or so. Well, let's come back to 50 and let's go up and see which company makes more sense to go with if you're only going to use the phone for 100 or anything less than, for 50. Company B, right? Company B is going to be a little bit less expensive at 50 minutes because it's down here. It's a little bit lower, right? So you're going to pay about $80 there, whereas company A, you're going to pay a little over $80. So if you're not going to use the phone a whole lot, it makes more sense to go with company B. If you know you're a talker and you're like, nope, I'm going to be using that phone a whole lot, come out here to 300 and go up and look and see which company is cheaper. And it's going to be company A. So depending on how the question is worded, it might say, where are they going to be the exact same? It might say, if you're only going to use the phone 50 minutes, what's a better choice? Or it might ask you, if you're going to use the phone a lot, what's a better choice? And you have to be able to think through what this graph means, okay? The best way I can say to figure it out is do exactly what I did. If it says, if you're going to do less than 100, what should you do? Pick a point less than 100 and go up like I did here in this red and just test it. And then just see what makes more sense, okay? If you're a visual learner like I am, I usually have to put it actually out in front of me to be able to answer it, okay? All right. Let's see. Let's go to this try it. So they give us two examples here, okay? The first one, or they give us two equations here, sorry, and they made it easy. They already have them in y equals mx plus b. So if we graph this first one, okay, we'll call this purple. If we graph the purple one, we know that for the purple one, we need an M and a B, and it's right there. Whoops. What's our M here? Yep. And what's our B? 5. Good. Right? Here's the M. Here's the B. Okay. So we begin with our B. So we put a point right at 5 on the y-axis, which is way up here. Now, think about that. I want to review this. We've done this, but I want to review it. Our slope really needs to be a fraction, right? So I'm going to put it over 1 because I know I can do that. And what that means, I'll just put it up here. 3 over 1 means I need to go up 3 and to the right 1 because it's positive, positive. But I don't have room to go up 3. I run out of graph. Is a negative and a backwards the same? Is positive, positive, and negative, negative still a fair thing in math? Both are positive. Negative, negative goes positive. So if I can't go up and positive to the right, I can go down and backwards to the left. And if I do negative, negative, I'm keeping that positive slope. So from my purple point here, from my B, I'm going to fall 3, 1, 2, 3, and go backwards 1. And I'm going to do that a couple of times to give myself a good line. So I'm going to fall 3 again, go backwards again, make a big point. I could even do it one more time and go backwards again. Notice I gave myself 4 really nice big points to connect a nice straight line. I will give you a big hint here, guys, use a ruler or a straight edge, because if you don't use a straight edge, you're going to have a hard time knowing where they really cross. Okay. So I gave myself several good points so that I have a nice, good area to lay my straight edge on. So there is my, would be straight if I had a ruler, but there's my nice straight line. And that is for the purple one. Now I'm going to come back here and I'm going to look at the second equation, which I'll call this my green one. And for that one, I need an m and a b, and it's right there. My m is 2/1, right? And I know I need it as a fraction. And my b is right here. It's 4. My b is where I begin. So I put a point right on the 4. Now I'm kind of in the same situation. I really need a +2 and a +1, which is up and to the right. I don't have room for that, but I know I can go negative, negative. So I'm going to go down 1, 2, and backwards 1. Well, can you already see the point where they both hit? I can do that a couple more times if I want. I can go down 2 and backwards 1, down 2 and backwards 1, down 2 and backwards 1. And even though right here, they kind of look like they cross, they really don't. So I would go with the 1 ordered pair, which was right where the 2 landed when I counted my slope. And this, I'm going to go ahead and connect those points to give myself the green line. Okay, and you can see here why you really need a ruler, because that is really not a straight line, but we're going to say it's straight for my poor little hand drawing here on my iPad. But what we did find when we counted down 3 and backwards 1 on purple and down 2 and backwards 1 on green, we noticed that both of them landed a point right here. So we know from counting our slope, we know that they both landed there. So we know that that's the one place where they crossed. Okay, so what is that ordered pair? Again, you got to think about above the x and side beside the y. So what is the x value of our ordered pair? -1, and our y value is +2. So the ordered pair is -1, 2, where they cross. So we're not just saying that it's one solution. Now we're actually getting specific if it's one solution and saying what is the solution, okay? Takes a little bit of precision, so you got to kind of slow down when you're graphing and make sure you're using neat points and using your slope to really get very specific points, okay? All right. I'm not going to spend a whole lot of time here. The only thing I will review is, because this seems to be what is a sticking point for some of us still, is that second one needs a little bit of work. Always think about the first step is get that x moved. So I'm going to -2x and -2x. Right? That's going to make these two go away, leaving me -2y equals. I can't add -2 and -2x. I have to keep them separate, and I want my x first. So I'm going to write it in that order. I still need my y by itself. It's attached with multiplication, so I'm going to divide by -2 all the way across the board. And I'm going to get y equals, right, because that goes away. -2 divided by -2 is 1x. -2 divided by -2, this should look familiar. It was your jump start. That's why I picked it as your jump start. Okay. So the first one was already in y equals mx plus b. That was here. The second one we put in y equals mx plus b. That was here. And then look at the graph, right? They graphed the blue one here. They graphed the red one here. We already knew from the slopes, because the slopes were the same, the y-intercepts were different. We knew it was going to be a no solution answer because the intercepts were different and the slopes were the same, but the graph kind of backs up and proves that what we thought was right is right, okay? And then same thing here, other than just practicing moving things around, not really a whole lot we need to say here as far as how it ends up. But let's go ahead. It's a -3x, so I'm going to add 3x and add 3x. That makes that go away, leaving me 6y equals, again, I cannot add 3x and 18, so I'm just going to write them, keep them separate, and then I'm going to divide by 6 all the way across. And when I do that, my 6's go away, leaving me my y, which is what I wanted. 3/6 reduces to 1/2. The x stays the x. 18 divided by 6, they're both positive, so it's +3. Well, now you should notice, right? You've got slope of a half, slope of a half. You've got a b of 3 and a b of 3. So it would make sense that when we graph them both, they graph, you can't even tell the difference. They're both there, but they graph the same. And so that is why we get infinitely many. But in this assignment, you're going to be asked to actually graph them. So you do have to go that extra step and graph them. Okay. Let's see. I'm going to skip this try it, and I'm going to go down to just show you. This is the key concept spot. This is always a great place to go. Whenever I say, when you come up to me for help, and I always say, go get your workbook, because you're going to use your notes in your workbook. This is always a great place to go to. For one, it's not in your own handwriting. And if your handwriting is not great, this might be a little bit neater area. Of course, you can always go up to the examples that we worked, but this is a nice place to start. Okay. The one thing I want to, let's see, go over is, yes. So I want you to circle number 7, number 8. Don't X out the whole problem, but just put a little X over number 9 number, but we are going to work this tomorrow, but we'll work it together. Okay, so we'll do this one on your homework together. And then everything else is 10, 11, 12, and 13. 10, 11, 12, and 13. Okay, that is your homework. So that's what you need to have done at the beginning of class tomorrow. At the very beginning of class, after I've checked your homework, we will all do number 9 together. And then everybody will have their homework done. Now, something I do want to call your attention to, number 11 says estimate. None of the other ones do. All of the other ones say determine the solution, state the solution, whatever. Why do you think number 11 is estimate? It's got decimals. And you remember when I said, when you're doing your own line, when I said when you're doing your own line, try to make sure your B is on a nice whole number. It just makes life easier. That's why. So here, you're going to just do your best, right? Use the decimals. You're going to estimate. And then when they cross, they're not going to cross on a nice, pretty, like, gray crisscross like this, right? These are all good points. Remember when I said pick a good point? We like good points. You're not going to land on a good point here. It's going to be one that you're going to have to estimate, because it's going to be something like, and I'm not saying where it's going to be, but it'll be something like this, right? So you're going to have to estimate what that is. All right. So that's why it says estimate. It's the only one that says estimate, but I did want to call your attention to why it's a little bit different. Okay. That's your homework. Like I said, we'll do number 9 together. Don't worry about the higher order of thinking or the assessment part. If we have time tomorrow, we'll do those. And if not, then we won't. But I'm not worried about that. I'm just worried about you getting up to 13. Okay. And that is it. For those of you at home, if you have any questions, check out the links on Canvas, and then you can email me if you need to.